7-4, rational exponents. What do they mean by rational exponents? Not all exponents are integers. Exponents that are expressed as a fraction are called rational exponents. One of the most commonly used rational exponents is half. The expressions with an exponent of half can also be represented as a square root. So remember the square root symbol. This just means square root of x means the same thing as x to the 1/2 power. So for any non-negative real number b, b to the half power is the same thing as saying the square root of b, and conversely, the square root of b is written as b to the half power. So you can convert from one form to the other. So 64 raised to the half power means the square root of 64, and the square root of 64 is 8. So you are likely familiar with square roots of a number. In the same way, you can find other roots of numbers. For example, if a cubed is equal to b, then a is the cubed root of b. And if a to the nth power is b, for a positive integer n, then a is the nth root of b. So when you're looking at radicals, the index, which root are you looking for, is always a small number there. The only time you will not see a number there is if it's the square roots, which means it's a 2. The radicand is the number inside the box, inside the symbol, radical symbol, and you have your radical symbol. So this means, what do you multiply by itself 5 times, get 18. So, for example, you would write this as the 5th root of 18. 5 is the index, 18 is the radicand, and then you have your radical symbol there. Some numbers have more than one nth root. Because 3 squared equals 9, and negative 3 squared is also 9. Both 3 and negative 3 are square roots of 9. Similarly, because 2 to the 4th power is 16, and 2 to the negative 2 to the 4th power is also 16, both 2 and negative 2 are 4th roots of 16. So they're asking you for the roots. You will need to put both positive and negative. But when there is more than one real root and n is even, the non-negative root is called principal root. So when they're asking for the principal root, or you're just looking for one root, you're always going to use the positive root. So radical symbols indicate principal roots. So the 4th root of 16 would be 2. So rational exponents for any real number b and any positive integer n, b to the 1/nth power is the same as finding the nth root of b. And going back and forth from one version. So this is exponential form. This is radical form. We're going to practice that right now. We're going to write each expression in radical or exponential form. So right now we have this as exponential form. So I can rewrite this in radical form as the square root of 10. Letter B is in radical form. To put it in exponential form, I have 7k squared, and I need to raise this to the 1/2 power. But I can simplify this a little bit further. So this would be 7 to the 1/2 power k, because I raise a power to a power, I multiply the exponents, and I would get 1k to the 1st power. So remember, in a previous lesson, your answer is not simplified until you don't have any powers raised to a power left over. Next, this is exponential. So I need to write it as a radical. So the half is only on the g. So the 2 is on the outside, and I need to find the square root of g. And letter D, square root of 86, 86, and I have to raise that to the 1/2 power. A couple other examples here. 2y to the 1/2 power. Now 2y is in parentheses, so I have both of those as the radicand. So the square root of 2y. And the radical as an exponential, since this is in the radical, I need 20z raised to the 1/2 power. A few more, write these as radical or exponential forms. So this would be 16p in parentheses raised to the 1/2 power. Letter B would be the square root of 34. C would be 8 times p to the 1/2 power, no parentheses around 8p, because the p is the radicand, so only the p should have the exponent. And the last one, square root of 3p. So another root besides 2. So 243, we need to evaluate this. This means, what do I multiply by itself 5 times to get 243? One way to do this is rewrite this as an exponential. So this would be 243 raised to the 1/5 power. And then you can easily go to your calculator. So I'll show my calculator here. And we can type in 243, use the caret symbol, and then in parentheses we would do 1 divided by 5. That gives us our 5th root, and that would give us an answer of 3. So the 5th root of 243 would be 3. Now the next one, the 4th root of 625. Whenever you have a 4th root, you can think of find the square root of 625. Square roots of 625 is 25. And then I find the square root of that one, and that would give us 5. So the 4th root of 625 is 5. Or you could also write this as 625 raised to the 1/4 power and use your calculator to solve that one. We can do 625 raised to the 1 divided by 4. It's important that you put your parentheses when you're using a TI-83, because always it's going to raise it to the 4th power, or raise it to the 1st power, and then you're going to divide your answer by 4, and you'll get the wrong answer. There you can see the answer is 5. Next, 256 raised to the, find the 4th root of that. If I find the square roots of 256, square roots of 256 is 16. And then if I find the square root of 16, I would get an answer of 4. So the 4th root of 256 is 4. And then 128, the 7th root of 128. On our calculators, we would just do 128 raised to the 1/7. And that would give us an answer of 2. Other ones, the 4th root of 4096. So I would do 4,096 raised to the 1/4 power. You could also find the square root of that and then find the square root of that answer. So if I did square roots of 4096, I end up with 64, and the square root of 64 would give us 8. And then the last one, do 16,807 raised to the 1/5 power. Grab our calculator. We got 16,807. We want to raise that to the 1/5 power. That gives us an answer of 7. Next, evaluate exponential expressions with rational exponents. So evaluate each of these expressions. So we just did this in the previous ones. So we were converting it to rational exponents. So the 6th root of 4,096, just do 4,096 raised to the 1/6 power, and you would get 4. And then 343 raised to the 1/3 power, this would give us 7. A couple other ones using calculator. I showed you earlier on the calculator, but if you need another refresher on it, use a calculator. 625 raised to the 1/4 power. We did this one earlier. We said that this one was 5. You'd enter 625 in the caret symbol raised to the 1 divided by 4 in parentheses and hit enter, and you get 1/4. So the cubed root of 127, which means raised to the 1/3 power. So I'm finding the cubed root of 127. So what do I multiply by itself?
3 times to get 1, that would be 1. And what do I multiply 3 times to get 27? That would be 3. So the cubed root of 1/27 would be 1/3. Next, evaluate this. Here we need to find the fourth root of 81. The fourth root of 81 is 3. The fourth root of 256 would be 4. So our answer would be 1/4. Next, we would have 100,000 raised to the 5th power. So this one with powers of 10, those are a little bit easier. So what do I multiply 5 times to get 100,000? You'll notice that there are 5 zeros. So that means this would be 10. Because 10 times 10 times 10 times 10 times 10 times 10, do that 5 times, you would get 100,000. Next, the power of n roots. The power of a power property extends the definition of b to the 1n power to include b to the n divided by n power. So b to the n divided by n means b to the 1/9 raised to the n power. Tray means raising a power to a power. When you raise a power to a power, you're multiplying your exponents. So m times 1 over n is m divided by n. And if you put it as a radical, the exponent is on the outside, and then the denominator of your exponential is your root, your index. The m goes as your exponent on your base. So you can either write this way with parentheses with the exponent on the outside, or you can put the exponent on the inside of the radical. So here you can see some examples. The cube root of 27 squared is the same thing as saying the cube root of 27 and then square that one, which you can write as an exponential, which would be 27 raised to the 2/3 power, which is 9. So let's take a look at some other examples here. 4 to the 15/5, which simplifies to 4 cubed. 4 cubed is the same as 64. And then 6 to the 7/7 power, 7 divided by 7 is 1. 6 to the 1st power is itself, which would be 6. So let's simplify these. So if we're evaluating these, this is really saying what's the 6th root of 729? And then I'm going to raise that to the 5th power. So we're going to grab our calculator here. And on here, let's do 729 raised to the 5/6 power. That would give us an answer of 243. Next one, 49ths. So if I were to find the square root of both numbers, if I find the square root of 36 and the square root of 49, and then cube all my answers, I would end up with 6 over 7. And then if I cube that, 6 cubed is 216. 7 cubed is 343. So our answer would be 216, 343. So if I go back to my calculator here and put that in here, let's do parentheses 36 divided by 49, end parentheses raised to the parentheses 3 divided by 2, end parentheses. See, we get at the decimal, but if I hit math, hit number 1, fraction, there's your 216 over 343. Next, evaluate these. Here's the 4th root of 16 is 2, and then 2 to the 7th power. 2 to the 7th power is 128. And over here, if I find the cube root of 216, the cube root of 216 is 6. Cube root of 64 is 4. Then if I square those, I would end up with an answer of 36 over 16. And that would be my final answer, but we could simplify that further. If I take 36/16 and I divide this by 4/4, I end up with 9/4, and that would be our simplified answer. And remember, all our answers are simplified when fractions are in simplest form. So just erase the box around here. Our final official answer is 9/4. Next, 49 to the 3/2 power. So the square root of 49, and then cubed it. So that's 7 cubed. 7 cubed would be 343. Then 243 to the 1/5 power. 243 raised to the 1/5 power would give us 3. And then I have to cube it, which will give us 27. Example 5, applying the rational exponents to group problems. So for A6, the resting metabolic rate can be determined by R equaling 4.14 times m to the 2/3 power, where R is the resting metabolic rate in cubic milliliters of oxygen per hour, and m is the body mass of the insect in milligrams. Determine the resting metabolic rate of a 125 milligram ebony blue wing angelfly. So R is the resting metabolic rate. We need to find that. So if the M is going to be the body mass, and the body mass is 125. So R is going to equal 4.14 times 125 raised to the 2/3 power. Now the cubed root of 125 is 5. And then I have to square that, and then multiply it by 4.14. So 25 times 4.14 will give us an answer of 103.5. So the metabolic rate of the damselfly would be 103.5 cubic milliliters per hour. Next, the frequency of a note hertz or vibration per second played on a perfectly tuned violin is given by f subscript n equaling 440 times 2 to the n/12th power, where n is the number of notes above the note A4. What is the frequency of A6, which is 24 notes above A4? So I need to find the frequency when it's 440 times 2 to the 4/12th power, or 24 divided by 12. So the n is 24, because it's 24 notes above A4, which this would be 440 times 2 squared. 440 times 4. 440 times 4 would give us 1,760. And our label would be hertz. Next, the profit P in thousands of dollars of a company is modeled by the equation P equals 3.7 times C to the 6/5, where C is the number of customers in thousands. Determine the profits of the company if they have 32,000 customers. So 32,000 raised to the 6/5. So if I did 32,000 raised to the 6/5, and then multiply that by 3.7. So normally if you put 32,000 in there, you're going to get the letter D as your answer. But remember, they're saying the customers are in thousands. So they're telling us that the customers, we're not going to put 32,000 in there. We're going to put, because that's representing the thousands, we're going to actually put 32. So if you put 32 in here, 32 to the 6/5 power, and then multiply by 3.7, you end up with 236.8, which would mean in thousands. So that would be 236,800, which would give us letter B. And example 6, our last examples for today. Simplify each expression. So I need to raise everything to the 0 power in this first one, which will make that 1 times find the half root of each. X squared to the half power is just x, and then y to the half power would give us the square root of y. So our answer would be x square root of y, or you could have it as x times y to the 1/2 power. Next one, like bases, I subtract the exponents. So 4/3 minus 2, which would be the same thing as saying 8/4 minus, multiply this by 3/3, which would be 6/3, and we would get 8 to the negative 2/3, and 8 to the negative 2/3, we can't have negative exponents in our answers. So I would have to do the reciprocal of that one, which would make this 1/8 to the 2/3 power, which I can rewrite this as the cube root of 8 is 2. 2 squared is 4. So this is really 1/4. And 1/4 would be my simplified answer. And letter C, need to multiply those. So I'm going to do 1331 raised to the 4th power. So when I multiply like bases, you're going to add the exponents. So they both have 1331. So when I simplify this one, this is going to be 1331 4 plus, this would be a negative 8/3. So I have to add those. This would be multiplied by 3/3. I would have 1331 12/4 or 12/3 minus 8/3. 12/3 minus 8/3 would be 4/3. And then I would take 12 to the 4/3 power, 1331 raised to the 4/3 power, and I would get an answer of 14,641. Now you would get the same answer if you just put that in the calculator just exactly like this, but to show the exact work on how you would solve it, you would go through that process. And a few other problems here. We have like bases, so 81, we can subtract the exponents, so 3/4 minus 5/4, which will give us 81 to the 2/4, which means negative 2/4 be 81 to the negative 1/2 power. If I rewrite this, this would be 1/81 to the 1/2 power, which the square root of 81 is 9, so this would give us an answer of 1/9. And letter B, anything to the first, raised to the first 0 power is 1. And the square root of 25 is 2, or is 5 times raised to the 3rd power would give us 125. Our answer would be 125. And the last one here, we have 6 to the 5th. You multiply like bases, you add the exponents. So this would be negative 6/2, which would be negative 3, which will give us an answer of 6 squared, an answer of 36. And one final problem here. Evaluate each expression. So for this one, 129, so we got 1296. When I divide like bases, I subtract the exponents, so this would be 2/4. So I would have 1296 raised to the 1/4, and 1296 raised to the 1/4 power gives us an answer of 6. Next one, 6 to the negative 4th plus 10/3, which is the same thing as saying 6 to the negative 12/3 plus 10/3 will give us 6 to the negative 2/3, which will give us 1/6 to the 2/3. and 6 raised to the 2/3 power I noticed I just made a mistake. That's a 64. That would make more sense. So 64, the cube root of 64 is 4. So we do this would be 1 over 64 to the 2/3 power. The cube root of 64 is 4. And then I square it. That would give us 1 over 16. And our last one, anything to the 0 power is 1. So then that would be times 2/5 times 5 would be a squared, and then b to the 5th. So our answer is a squared b to the 5th. So that is our lesson on rational exponents.